It's my privilege to welcome Dr. Sudhir Khare, Scientist G at the uh, IRDE DRDO. He has been engaged in research, design, and development in the area of thermal imaging for the last 25 years. His research interests include systems design, infrared signal processing, and performance evaluation of thermal imaging systems. He has published more than 20 papers in journals and is also a life member of the Optical Society of India. He is a recipient of the DRDO Scientist of the Year Award 2017 and the Agni Award for Excellence in Self-Reliance in 2009, 2012, and 2014. Over to Dr. Khare, please.
So I'm starting, sir. My topic is latest technologies and challenges in night vision, especially in the thermal infrared technology. So, sir, this is everybody knows this electromagnetic spectrum, and the IRD thrust area is in these bands, this visible and infrared. And visible is from 0.4 to 0.7 micrometer, and then IA tube based system 0.4 to 0.9, and then short wave infrared 1 to 3 micron, medium wave infrared 3 to 5 micron, and long wave infrared 8 to 12 micron. So we are working on all these bands starting from visible to infrared. It is just I'm starting with the brief of the elements of thermal imagers. So this infrared radiations or photons are coming from the target and background, and after propagating through the atmosphere, these radiations and photons are collected by the infrared optics, and then these radiations are focused onto the detector. It is the heart of the system. This detector is the integrated detector devar cooler assembly also in case of cooled, and in case of uncooled detector it is a microbolometer type, and this detector converts this radiation into the electrical signal, and then we are processing this signal and we are displaying the image on the any TV compatible monitor. And all these factors are very important, like in case of target and background, like the size of the target, what is the contrast, clutter, operational scenario. Similarly, you will not get all the time the same picture, because atmosphere also plays the major role, the absorption, the turbulence, scattering, and all these atmospheric effects, basically environmental effects. And then the optics, what is the field of view, what is its resolution. Similarly, the detector, the array size, what is its f number, and the wavelength and frame rate, and all these things. Similarly, in case of signal processing also, we need to do lot of image processing to get the good image, and of course the display, the size matters, the resolution of the display matters, and above all, the human observer, for seeing the thermal images and videos, some training is also required. So the observer has to be trained also for this. And as we all knows, because of the atmospheric effects, basically the performance of thermal imager degrades in the turbulence or fog or rain. These are some of the features of the thermal imager. It is truly passive and operates in the total darkness, and it is less affected by the smoke, dust, or light rain. You can say this is the image snapshot taken with the smoke, and with this TI you can see clearly the image. Similarly, better fog penetration capability, because it is inversely proportional, lambda is inversely proportional, so scattering is less in this, so better fog penetration and the longer detection possible. This is you can see the target at 17 kilometer, and with the appropriate optics module we will get ranges more than 40 kilometer with the thermal imager and all, we have already realized. And it is not blinded by any searchlight or flares, you can see, and because it detected the heat, so it reveals the thermal detail of the scene. If you can see in this is the picture taken from the day camera, and here you can see this is the thermal image where you can see this hand, because of it detects the heat and it remains heat remains for some time. So you can reveal the thermal detail of the scene also. Then as technology is changing in the infrared region, so these are the emerging requirements from user also. User is asking now the improved and longer ranges in various atmospheric conditions. And similarly, the recognition ranges may be more than 40 kilometer, 50 kilometer for the airborne type of targets. And similarly, user wants the large field of view. The field of view should be large, and the reduction in size, weight, power, and cost. And as I will explain also, the multiple bands, use of multiple bands, all these bands are having their advantages and disadvantages. So use of multiple bands, the SWIR and medium wave and long wave also together, and then the data and image fusion, and the use of spectral information for the better discrimination, like the multispectral and hyperspectral. So these are some of the technologies which we will be using to deliver these type of system, the large steering arrays, dual band, multispectral, hyperspectral type of systems, the faster frame rates, and the higher operating temperature. Because as we know, this detector has to cool down to 77 Kelvin, and it takes about 6 to 8 minutes to 10 minutes sometimes, depending upon the application, to get the picture. But in some of the application, the readiness time is not this 6 minutes or 8 minutes or 10 minutes. It should be ready by as early as possible. So there are detectors available which are operating at the higher temperature. So we have realized the system which are operating at higher temperature, like 150 Kelvin. That also I will be covering. These are the three bands: the long wave infrared 8 to 12 micron, and then medium wave infrared 3 to 5 micron, and short wave infrared 0.9 to 2 micron. So all the bands are having their advantages and disadvantages. Like long wave infrared, it has the better transmission in through the dust and the smoke, and these systems are very good for the ranges less than 6 kilometers. That is why for the tank application, we generally use this long wave infrared as a gunner sight, and target to background contrast is also very high. Flux is very high in this long wave, and VG arrays are now available, like third generation 640, 500, 12, 15 micron detectors are available in long wave infrared. And similarly, this medium wave infrared, the better transmission in hot and humid conditions. So for the longer ranges, we use this medium wave infrared, and especially for the maritime environment in the naval application also, we use this medium wave infrared cameras, and it has the smaller aperture with respect to long wave for the similar ranges, and technology is mature, and megapixel detectors and arrays are available in this medium wave infrared. So megapixel like 12 HD detector 1280, 1024 are available, then 19, 20, 13, 20 also available. So these type of detectors are available in medium wave. Similarly, in SWIR band also, it is very close to the visible band, so the image look like the non-synthetic look, and short range is only possible unless the target is illuminated, because it uses the reflection also, and it is very good at the time of dusk and dawn, and in the light haze, where it is the basically SWIR imagers are basically replacement of the day camera nowadays. So user is asking SWIR camera in place of the day camera, because it is very good for the light haze and all, where we cannot see with the day camera or CCD type of camera, we cannot see in the haze and all. And here also these are cheap detectors available in the compact size, like HD 1280, 1024 and megapixels arrays are available in SWIR region also. This is just the thermal imager generation. This first generation, we have realized system based on the 60 element, only one 60 element, one column is there, or 121 column is there. Then we used to scan the whole field of view to get the 2D or 1D image. And the optics is also very complicated, and we used to use this optomechanical scanner, which is very bulky, and power requirement is also very high. And then this second generation detectors came with the mercury cadmium telluride 288 into 4 and 480 into 4, like 280 detectors will be there, 288 rows and 4 columns will be there. Here also we require the scanning, but it is better than first generation, and sensitivity is also better than first generation. But now with the technology advancement, now third generation detectors are available, which covers the full field of view. You can see it covers the full field of view, and the material, indium gallium arsenide and mercury cadmium telluride and indium antinomide, type 2 superlattice, and uncooled also amorphous silicon and vanadium oxide detectors are available in the market. And the format is starting from 320 to 640, 512 to HD 1280, 1024, and megapixel 1920 and 1536 format also. So with the technology advancement, we are getting now third generation, and this element size is also starting from the 30 micron, 20 micron, 17, 15, 12 and 10 micron are available. So if you go from the 30 micron to 10 micron, definitely we will have the advantage of the high resolution system, and which will provide you the like longer ranges. So I am starting with some 2-3 case studies. We have used this technology for the night enablement of AFVs, and these technologies for in-service armored fighting vehicle with enhanced night fighting capabilities basically. So this in-service AFVs are total 5,000 numbers, and these are the T-72, T-90 and BMP tanks, and existing these tanks are having this IRDE based sight for their commander, and the recognition ranges in night is only for 700 meter in night and 3 kilometer for the day. Similarly, in T-90 also commander can see up to 700 meter with this IITube based sight, and BMP also. So we have taken this mission mode project, and we have realized this these sites in form fit configuration, which enhances the commander ranges from 700 meters to 3 to 4 kilometers. So these are the technologies and challenges because it's a retrofitment solution. These are the Russian tanks, and we have to modify or upgrade these sites in form fit configuration without any armor cutting. So this was our limitation, dimensional limitations. We don't have in form fit configuration. We had to provide, and the functional replacement of night sight. Only thing is, like, we have to retain the day sight and just replacing the IITube based sight and enhancing the recognition range with the dimensional constraint. So use of contemporary technology we have used, and indigenous electronics modules also we have used as per the user requirement. And in T-90 the user requirement was also for firing also, so we have implemented the laser range finder also, and it was very difficult to incorporate the LRF in that small space. So we have used the common channel optical design for the existing day sight and LRF, and then we have given this full technology to our production agency, Optoelectronic Factory, which is the India Optel Limited, and the Bharat Electronics, Machilipatnam. And we have successfully transferred this TOT to these production agency, that we have established the test facilities there and established the process for production of the critical modules. So this is the T-90, and here is the commander sighting system, and this is the inside. You can see this commander sighting system. This is a snapshot during the field trial, and this is a small, just a small video. You can see the picture quality. And this is the, you can see this is the PKN4S of the T-90 site, and this is the TKN3 site of T-72, and these are the specification. We have used this 640 into 512 detector, and recognition ranges for the tank target is 3 km for T-72 and BMP, and 4 km for the T-90. So these were the total quantity as per the DAC decision. And all these sighting systems are under production at production agencies Bharat Electronics and Optoelectronics Factory. And only for the T90, this 1193 sites, this is just CNC is completed and order is very soon going to place on the Bharat Electronics. Otherwise, all systems are under production at Bell. So this was the first system where we have used this third generation sensor technologies. Similarly, we have developed one this LWIR third generation detector based on the type 2 superlattice material. So this detector we have developed under the Indo-Israel Management Council by the joint funding between the DRDO and Israeli Ministry of Defense. And SCD Israel, Semiconductor Israel, has developed one detector type 2 superlattice LWIR detector. And we have used this detector to develop the gunner sight for T90. As we know, this existing TI for gunner T90 is Catherine FC, which is the first generation based on first generation detector. And with the latest technology upgrades, these sighting systems are obsolete and spares are also not available. And these sites are unserviceable. So we have taken up to replace these sites. And as per the alteration committee decision, we have developed this thermal imager in form fit configuration again, and realize the sighting system. All the trials in user trial, DGQA, MET and EMI-MC, all trials are over, and presently this is under GS evaluation. You can see the picture quality of this imager. Similarly, you can see this is the one video captured during the cross-border attack.
Normally not clearly visible on HSTI. Now this is
so in this operation, basically this second generation HSTI, which are in service with Army, have been used, and this is spectral band is 8 to 10 micron, and this detector is 288 into 4. So as I already told, there is now requirement for using the multispectral basically. So we have realized one handheld thermal imager with laser rangefinder, and this is having the 5 sensor, this laser rangefinder, CCD, GPS, DMC, and TI, and spectral band is 3 to 5 micron. So this is based on the third generation 320 into 256, and weight is around 3.5 kg with the battery endurance of 4 hours, lithium ion batteries. So these HSTI, if you see again, this is based on the 320 into 256 SWAN detector, which we have developed as per our specification under Israel Management Council. And this recognition range for these HSTI is 3 km for the tank size of target, and for human target it is 2 km. And these more than 4,000 number sites have been already delivered to Indian Army, and Northern Command has also purchased numbers for their operations. And very comprehensive user trial for these sighting system, including the high altitude area of Leh, have been carried out. Similarly, in Uri attack, these HSTI devices have been used, but this could not fire because weapon is not integrated. So now IRDE has taken up the project to develop a system with weaponization of HSTI, and we have proven the concept also and demonstrated to Northern Command. You can see this is the in-service HSTI, and this is the in-service MMG and LMG. So what we are doing, both are the remotely located, and this HSTI will be at the observation post, and weapon station will be somewhere, some other post basically, and both the things are harmonized together. So this is the aim and fire configuration. We can see through the HSTI and we can fire from the MMG, and this we have already proven the concept and demonstrated to Northern Command recently, and we are realizing the ruggedized version also. Similarly, like multi-factorial surveillance system, we have realized this system, you can see this is broadband system from 0.4 to 5 micron. It is covering all the bands, and it is having the CCD camera and SWIR band also, and MWR band also. And this camera is presently we have deployed in Kumayu region near the border area. You can see these are the image captured from the MWR camera and short wave, and then the broadband image. And we can see the, because SWIR is 0.9 to 1.7 microns, so we can see the laser spots also. Because if we are using the eye-safe laser, so it is 1.54 micron is the wavelength. So we can see the laser spot also, the beauty of this system. We can see the images. Similarly, this high format and this low pitch detector. So benefit of the large format using the large array size is basically we get the large field of view, large coverage, and the smaller pixel improves the basically resolution of the sighting system, and which improves the overall ranges. So for higher ranges, if we use the low pitch detector, so the system will be lightweight, not bulky. And if we use the higher pitch detector, so it will be, optics will be very large with the higher focal length, and system will be very bulky. So we have realized this megapixel sensor. This is 1920 to 1536. So we have done this comparison also. So you can see this 12801024 15 micron 5.5 detector number is comparable to 1920 1536 and 10 micron f4. These two detectors will give the same performance. So you can see the benefits of this megapixel system. Basically we can zoom. You can see this is in 4x zoom, because pixel size is very small. It is just a 10 micron. So if we use the electronic zoom also, then you will get the very good picture quality. You can see at the 8x or 16x, and you can see here also very good picture quality you will get with the electronic zoom. So it is system also will be very light, because there will be we will be using only the electronic zoom. This is the megapixel camera which we have realized, and it is integrated with the small day camera and LRF also. And it is very useful for the border application or aerostate or for UAV and naval application. Then this is the broadband detector, like 1 to 5.4 micron detector based system. So it is having the SWIR image in addition to MWIR also, and this daylight SWIR results gives you the very large surveillance ranges. Okay, and today's requirement is the laser devices also. So what is the beauty of this broadband detector is it is having the laser diode also. So we can find out the each pixel behaves like a laser range finder also. Okay, so each detector pixel is having the laser diode, so it serves as a laser range finder also. So you get the ranges also directly. So you can see this MWR image and SWR image. And here you can see the laser spot also. So this is having the advanced LRF abilities also in addition to MWIR and SWIR region, and we can see the laser spot also. And definitely it is going to be very this improved identification in 2D mapping. You can see the benefit of the multispectral. Like if we use the long wave infrared, so it is good for the temperature measurement and the detecting the relatively cool objects as far as long wave infrared systems are concerned. Then the short wave infrared, these systems basically uses the reflection also, so it is very good for the detecting the non-deflecting things like the detecting the water, and it is very close to visible band, so is providing the non-synthetic type of image. Similarly, MWIR is good for detecting the relatively warm objects, and visible is we see is a high resolution and color, and it provides a very high resolution. So these are the advantages of the multispectral. So there is a trend to use these multispectral detectors. And now this is the high operating temperature detector. Hot detectors are available. You can see this indium antimony material and the indium arsenic antimony and noise equivalent temperature difference NETD. We are getting both same 25 millikelvin, and the weight is also very less, 290 gram, and this is the hot detector 185 gram. And this FP operating temperature is 77 Kelvin. And now for this hot detector, we require only 150 K. And then the cooling power is also very less with 2 watt. And cool down time is, which is maybe some 6 minutes or 8 minutes or 10 minutes, it has reduced to 3 minutes. And reliability also improved, like from 5,000 hours to 10,000 hours of the cooler. So cooling is also very lightweight in this. You can see the image quality, like 150 Kelvin also we are getting the very good image with the same sensitivity or same NETD. So these detectors are now available, and we have realized one sighting system, one handheld thermal imager based on this detector. These are the some trends in uncooled detector technology. So uncooled detector technology, I already told you that megapixel detectors are available with the 12 micron pitch or 17 micron pitch, with the NETD is also in the order of 30 millikelvin or so. And these uncooled detectors have their advantage. These detectors have like the helmet mounted sighting system and the rifle sights, like the small all the small arms basically, and maybe up to some 1 kilometer or 1.5 kilometer, these uncooled detectors are very good. And in missiles also we are using these uncooled detector in the infrared seeker modules. These are ready to use detectors, and we have also realized one advanced driver night sight. You can see the image also, and we have used the day camera also and fused the TI and day image, so you can see the beacon light and all in the night. We can use the beacon light, and this IR detector is 640x480, and it is fused with the day camera image, and field of view is 45 degree, and it provides you the PAL output, CCR output. So you can see the light also. This is night time. Here also you can see this is the TI image, this is the day image, and this is the fused image. And these are some of the basically challenges, the technology gaps, like the manufacturing of IDDCAs in India and the maintenance of these DDCAs. Similarly, for the uncooled thermal imagers also the same issue. So we have taken up one proposal for the TOT of these detectors in India, and we have prepared the proposals also, and it is submitted to our headquarters. So for this under Atmanirbhar Bharat, we want to establish the detector manufacturing facility in India. Then only we will be self-reliant. So this we are starting with the TOT of MWIR detectors, 640, 500, 12, 15 micron. And then maintenance of the in-service detectors like 320 detectors, 30 micron, 20 micron detectors, and it will be extendable to for the higher format detectors also, and LWIR. We are starting with the MWIR detector. These are the trends in infrared imaging, like the compact portable systems, and the size, weight, and power, cost, everything reduced. and improved the image quality and reliability. Similarly, the embedded system with the broadband and multispectral systems for the land, naval, air and airborne platform. And there is a trend for using the dual band thermal imager with image fusion. Similarly, we are working on the for airborne platform, the infrared search and tracker and the navigational and targeting pod for night fighting capabilities. So all this is we are doing, and the dual color missile approach warning systems, and we are working in this optronic warfare also.
I hope, Dr. Khare, you are closer to the end. Okay, yes, that I can
Yes,
see.
yes. Jai Hind, sir.
Thank you.